Hello, everybody. Welcome to our last chapter, kind of a mini unit we're going to have here in these last 4 classes before we go on to our final exam. As I said in my email, these videos aren't going to have necessarily a test that goes with them, but questions on logarithms will be on the final. And so that's how we'll assess this unit. Will be only on the final coming up here in a couple of weeks. So today we're going to introduce the idea of logarithms. And this is kind of a fun time because this is the first time in years that we've been able to introduce to you a new operation. When we say mathematical operations, we're talking about things like adding, subtracting, multiplying, dividing. These are all operations: plus, minus, times, divide. But so are things like exponents are operations, roots are operations. These are all types of operations, and a logarithm is an operation. And this is one of those days when we're talking about something and it's going to seem like it's going to be challenging or difficult because it's totally new, something you've never seen before. But in the same way that at one point, multiplying was new. Now, obviously, multiplying is something you have a very deep understanding of. So when you say, what is a logarithm is a question. And I'm going to go ahead and type this because it'll be easier. It's a question that asks, to what power? So it's similar to a root in the way that like a square root says what number to the second power. And it's similar to an exponent in the way that it's saying raising something to a power, but it's actually the opposite of an exponent. So it asks the question, to what power? So if I scroll down and look at these examples I have down here, and we see the way that you write logarithms. First of all, a logarithm we abbreviate as log, and that's the button you'll see on your calculator. But don't try to use your calculator to do some of these, and I'll explain why in a minute. But the question that's being asked here, you see what this says, log base 4 is how we say that, because that 4 is a little subscript there. So we call that log base 4 of 64. And we said logs ask the question, to what power? So we're asking the question, 4 to what power is 64? So we've asked that question, what power on 4 gets us to 64? So let's start counting by 4s, but we're doing a power. So that means we're not going to count by 4s, we're actually going to multiply by 4s. So 1 4 is 4. 4 to the second power is 16, times another 4 is 64. So it takes 3 4s multiplied together to get to 64. So therefore, log base 4 of 64 is 3. That's all we're doing. We're simply saying how many 4s multiplied together make 64. We're asking to what power, because that's what multiplying repeatedly is a power. All right, so now let's look at another example. For B, log base 2 of 32. All right, the first power is 2. Second power is 4, because 2 times 2 is 4. Times 2 again, 8. So the third power is 8. Times 2 again is 16. And then 16 times 2 is 32. So it takes 2 multiplied by itself 5 times to get to 32. So therefore, the fifth power got us to 32. So log base 2 of 32 is 5. Log simply asks the question, to what power? So you look at the little number, the subscript, and you say, to what power is 30? It is 32, and that's 2 to the fifth power. Now, example 3 brings up 2 other issues we need to talk about. You recognize the first thing that probably jumps out at you is it's a fraction, and we'll deal with that second. But the other thing you notice is there's nothing down here. We don't have that base, that subscript. And just like a lot of things in math, we have an expected value there. Just like how if there's nothing in front of an x, we know there's a 1 there. That kind of idea. Log without a base is always log base 10. So if you see a log button on your calculator and you just push the log button, it's going to do log base 10 because our number system is base 10. And so when you think of the powers of 10, 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. That's always where a new digit is added. And so that's where the log base comes from. It's log base 10 because that's how our number system works. Our number system is base 10. So if you don't have something written there, the original problem looked like this, then there's a 10 down there. So now this question is asking, we took 10 to some power and got 1/100th. Well, the trick here goes back to our exponent rules. Remember, when you want to move something to the bottom of a fraction, you use a negative exponent. So we know the exponent has to be negative, and then we can say 10 to what power is 100? Well, that's the second power. So therefore, log of 1/100th is -2. So anytime you have a log that turns a number into a fraction, you know your answer is going to be negative. All right, this is what a log is. This is the basic definition. Now, we're going to do two little things that are going to kind of look like this to kind of lock down our understanding of logarithms. So here we go. So the other thing we're going to do today is translating from logarithmic to exponential forms and exponential form to logarithmic form. And we're going to be going back and forth, and I'm just going to show you a couple quick examples of this because, again, this is all about the definition of logs. Today's homework is not going to take you very long at all. It's about a 3-minute homework assignment at best. So we've got two different problems here. The first one I've given to you in logarithmic form. Again, big words to say there's a log in it. And the logarithmic form, we're going to talk about what that means because I've given you a completed problem. I've already calculated the answer. Log base 6 of 216 equals 3. Well, what that means is what we're shooting for here. So what that means is if this is true, then we can take the information from the log. Log base 6 asks the question, 6 to what power gave you 216? Well, if the answer was 3, then that must mean 6 to the third power is 216. So this is what we call translating from logarithmic form into exponential form. So just basically declaring, here's how what we know. We understand what log means. Log asks the question, to what power? So if the answer is 3, then the power has to be 3. Because we said 6 to what power? Well, 6 to the third power, because your answer was 3. So if we look at the bottom, we have one in exponential form that we need to turn into logarithmic form. So it says 4 to the -3rd equals 1/64. That is a true statement. And we want to go ahead and translate that true statement and write it as a log, because logs and exponents are opposites of each other. So the log, now I'll always use a cursive L just because they look like ones if I don't. And so we have the log, the base of your log, here it was 6, 6 was the base of the exponent. So that means if 4 is the base of the exponent, 4 is the base of the log. Then it says, to be a log, I'm saying 4 to what power gave me that? Well, 4 to what power? Whoops, I wrote 16. That's supposed to be a 64. 4 to what power gave us 1/64? The answer has got to be -3. So we're translating. We're taking a logarithm and rewriting it as an exponent, or taking an exponent and rewriting it as a logarithm. That's translating. All you really need to know to do these is the base of our log is always going to be the same as the base of our exponent. The base of our log is the base of our exponent. And then these two numbers end up switching sides. It's kind of a shortcut way people remember that. But if you understand what logs mean, you can rewrite between one form and the other. All right, tonight's homework should be pretty quick. Like I said, we've got 4 log videos, and that's it. This is number 1 of 4, and then we are through the year, ready to focus on the final. All right, have a good night.